figure out how to do this. All right.
Okay. Hi, we're the Kennedy Langford team. I'm Amanda. I'm Emily O'Brien.
I'm Ferocity.
I'm Arjun Venkatesh. I'm Grant Sheely.
I'm Melanie Abzug. When we came to Crystal Group, we were faced with many problems, but we decided to focus on the problem of excess materials from kits.
And the first step is the Plan, Do, Study Act. And the first step is understand the system and select the team, which you already did. And then we had to define the problemtunity. What is a problem and where's the opportunity to fix this problem? We had to study the current situation within the company, analyze the causes, select and develop a new theory for improvement of our problem, and then we would have to implement the theory for improvement and study the results and learn from them. After that, we would standardize the improvement so it would work better, and then we would reflect and establish future plans.
So before we could start out with the different steps of this process, we made a code of cooperation amongst our group to better the environment in which we're trying to solve the problem. So we decided we wouldn't talk all at once and support each other's ideas, use our time wisely and efficiently, stay on task, and have fun. So as our step one in the plan process, we decided to use a flow chart, and as we were going from receiving sales orders to the finished product.
And we thought that the people involved were the operations, sales, materials, engineering, and finance departments. The first step is the sales order enters the sales order. Then materials team reviews the order and creates the jobs. And then afterwards, the materials team creates a list for each job of all the materials needed. Then materials distributes each kit on a cart to every section of the production floor. Various production areas build the required kits, and then they pass them on. And then later, further down the line, certain parts are returned to stock or removed, and then the final test of the computer runs for 24 hours.
So, and then for step two of the plan process, we created our problem statement, and we decided that the current problem was too much wasted time, materials, and labor.
And we decided that the impact that this current problem was having was the employees were wasting time by having to restock the materials, and the cost of the customers was increasing due to that. And if the problem was fixed, we hoped that the employees would efficiently use time and material.
We have another step two of the plan process, which was the bone diagram. And the bone diagram is a systems reflection and planning tool that helps organizations clarify the current and desired states. So that's the bone.
So our current problem is one of the reasons is lack of communication between employees, not just between the employees on the assembly line, but between the engineering and the operations department. Also the overstocking of products because of the excess materials from the kits. The unclear beginning and endpoints for the employees on the assembly line because they cannot see all the levels of the drawings, so they don't know that there are going to be modifications at the end. There's unnecessary labor for the restocking, and then there's a loss of money from the excess product. The desired state would be clear directions before the production begins, so they don't have to make modifications at the end. No loss of money and from excess materials, and then there'd be an efficient assembly line and no wasted materials.
Step three, we used the force field analysis, still part of the plan process, and we have our driving forces, which are preventing or slowing improvement, and then our preventing forces, so what is being done to prevent the problem.
We decided that the driving forces were sectioned work within the assembly line, lack of communication between the employees, unclear directions, and blaming of different workers and between the different sections within the company. And the preventing forces were recognizing that there was a problem to start out with.
Step four, we used a fishbone diagram where we name the causes and then the effect, and these are the causes and minor variations that lead to the effect.
One of the causes was lack of communication between the different groups within the company, and that resulted in unorganization. Another cause of excess material was the fact that Crystal Group makes customized kits for each of its customers. So with the customized kits, it results in too many varieties to make a drawing for every kit, and the beginning steps don't see the needed modifications at the end of the line on the production floor. And then the last cause was there are different levels of drawings and instructions that each worker sees, and this is caused by customized orders, each step of the assembly line not being shown all the drawings, and not all employees look at the provided drawings for later modifications. And then the final effect is excess materials on the floor results in unnecessary labor in the restocking rooms.
For step 5, we use the affinity diagram, which identifies and sorts large quantities of ideas using a voting system. So we all wrote down different ideas which we thought could solve the problem, and then we grouped together the ones that were most alike, and then we put it into the slideshow.
So each box represents one vote, and so our top two were making the original assembler fix the problem, but we realized that the original assembler couldn't see the drawings that show that they needed more modifications, so that really wasn't fair to them. So we decided to go with using Excel to find similar components needed down the line and flagging or highlighting duplicates leading to modifications.
So part 6, which is also part of the do process, so we're actually trying to get something going now, we have notes suggesting positive comments, needs for improvement, and general concerns, questions, or insights for review at a later time. So we asked these questions to the engineering department and production department to see how they felt about the issue.
Okay, so when we talked to engineering, we asked them what's going well, and they said production is quick and excess materials don't really hurt overall profit because usually the excess materials are then used in like a later order. But again, we'll talk about this later, but the company doesn't have any actual data, so one of our later steps will be taking data. What needs improvement? They said due to the speed, the process is too flexible, and Crystal Group is one of the reason they're really known is because of how fast they can get their products out. So their process is really flexible. They don't have a specific building materials for every order. And production does not like stocking and restocking or components when they're pulled out and not needed. And what are ideas for improvement or issues? They said that in a perfect world there would be a system of checks and balances between the engineering and the production team. And they said that a spreadsheet to highlight excess parts ahead of time to get rid of excess materials, and that's interesting because we also came up with that idea.
Alright, so then we went to production and asked them the same questions about how they felt about the problem of excess materials. And they said what's going well, new programs to check flaws that improved number of wasted materials 8 months ago was implemented. A program made production more organized with the first article check sheet. The assembly efficiency improved through straight lines. And then we asked them if they had any ideas for improvement, and they said redundancies happen often in the assembly line. Only building one base model at the end, they have to edit it often, and they want specific BOM structures for every combination. And a spreadsheet to highlight excess parts ahead of time would get rid of excess materials also. When we asked them if they had any ideas for improvement, they said more communication, more accurate BOM structures, changing the BOM structures in engineering to recognize redundancies in the BBS ahead of time, customer personalization, and allow the workers to know what the final product is ahead of time.
Okay. And so after we implemented our solution for collecting data, we decided to use a check sheet to show the data.
So this is our step 7, which is now part of the study process, and we use to determine how often an event is occurring by turning opinions into verifiable facts. So this is just like an example of what the check sheet would be, and and then we created 2 examples specifically for Crystal Group.
Alright, so the top one is we were thinking, since you guys have no data on really what, if there is a problem, maybe for 1 month you guys would mark how many products or components you guys are having to restock. So then you could compare with the data you would take after we implemented the solution, so you could see if there was an actual improvement. And if the Excel solution didn't work out, we were thinking for the second check sheet, you guys could mark down maybe what were the top 3 most restocked components, and then have someone look through the BOMs for a new order for those components, so you guys wouldn't be pulling those out.
So the solution spreadsheet, we'd use Microsoft Excel or Expandable to create a spreadsheet. The spreadsheet would consist of the VBS plus the kit and customer personalization, and it would highlight redundancies in the spreadsheet ahead of time. The assembly line would collect the correct amount of product due to highlights ahead of time, and excess materials would be eliminated, which would create a median between engineering and production.
So, step 8, we use the
Hold on.
Pope chart.
I'm gonna show an example
Okay.
of that, of what Grant was just talking about. So this here is like a list of the BBS, the bare bone system, of just a base computer. And down here is a kit that is some type of modification to be this base system. So what the stockroom will do is they will go and grab all these parts here and put it in a bucket, and then they'll see this kit and they'll go grab all these parts and grab it, put it in a different bucket. But as you can see, these highlighted ones are the exact same parts in both the kit and the BBS. So when it gets to the production floor, it only needs 1 fan. So this extra fan, for example, will just be sitting there, and then it has to be restocked. And if Crystal Group doesn't have this fan, or enough fans, then they're gonna have to go order more fans. And that costs a lot of money if it's a big order. And the other big problem we see with this is that they're not using this extra fan, but the customer is getting charged for this extra fan because it's getting pulled off it's in this list, so that's, yeah.
So, step 8 is the Pope chart, which lays out the purpose, outcomes, process, and evaluation, and it provides structure to an open-ended task. So we put the Pope chart in for our information that we gathered from the problem.
The purpose was to eliminate excess materials and cut costs and labor in the process. The outcomes were excess materials were taken away because they were informed about them ahead of time in the assembly line because of the spreadsheet. The process, incorporate the spreadsheet into every customer order that you get. The evaluation is implement the check sheet and see how it works.
And then for the final step, which is the ACT process, we're reflecting, and it's an if and then, which is a projection tool used for prediction of consequences of proposed changes. And so you start with the problem and then go from there. So we started with how do we efficiently reduce excess materials in production, and they said we had like 2 different paths. We said have regular company meetings, then we can communicate between departments better, and if we have better communication between departments, then we will be more efficient on the production line. And then our other suggestion was if we use a cross-reference sheet such as Excel or Expandable, which is the program here at Crystal Group, then we eliminate excess materials before going to the assembly line. And if we eliminate excess materials, then we reduce labor costs, time, and prices for customers go down. So while we were evaluating the situation here, we just came up with group ideas for improvement, just like start from, and then we could work further from there. And we thought we could have regular company-wide meetings so that everybody's on the same page and it addresses the issue of lack of communication, and track excess materials that need to be restocked or that have gone to waste, and create an expandable program to recognize duplicates between BBS and kit bonds, which is a bill of materials, to flag for later modifications. So we just kind of covered all the bases that we had previously addressed, and they can be implemented differently.
So, any questions? Yeah.
What do you got, Mike?